Hi everyone, welcome to our video on a variation on the substitution method. So it occurs when we have these scenarios where it's like a linear expression times another linear expression, or a linear expression divided by a linear expression. And what we'll do is this three-step process. So let's break these two problems down. So in this example 3 of number 1 here, we have this fraction. Okay, and so what we want to do is use our u to do, again, usually use the more complicated expression. So we're going to do u. Let's do it in blue. Okay, so my u is the x plus 5. And then as soon as I have my u, I want to solve for my du, which would be, okay, so the derivative of x is 1, and then attach dx. But at this point, we would just say, let's go ahead, dot, 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 du is dx. Okay, so because 1 times dx is dx. Okay, so I have my u and I have my du. Well, what's different here is, well, let's go ahead and still put this here in the blue parentheses. So that will be the u that we will sub in. But I have an issue with that top x. So du equals dx, that's no big deal. So that I could sub in as well. So this is already ready. But this top x I have a problem with. Well, what we will do, let's show it in green with this portion, is we're going to solve for x here, which is pretty easy. Just subtract 5. So x would be u minus 5. Let me try to rewrite that. Okay, so all I had to do was minus 5 to both sides, and all I'm doing is also putting just x on the left. So it's x is, so if I subtract 5, it'd be u minus 5. Okay, so I'm going to use this one right here that I'm clouding for this x. Okay, so it's kind of like a 3 substitution problem. But when we do that, so I have my integral, and then let's keep our color. So x plus 5 is we're saying, is just u. The green x is u minus 5. And then the dx, again, it has to make, we got to make sure it's all the same letter. So I don't want dx, but I have a direct substitution. Dx is the same as du, so I could sub that in right away. Okay, and so what we did this because now this becomes a better problem. Because I have a monomial in the denominator, I can now rewrite it as the integral of u over u minus 5 over u, and then du still at the end. Okay, so with the denominator being a monomial, I can split up the numerator into 2 separate terms. And then now each of these fractions I can simplify. U divided by u is 1. And then minus 5 over u is fine for now. We'll just leave it as is. And then du is attached. Okay, and then now it's ready to do the antiderivative. So we can do it. I'm going to show it in purple again. So the integral of 1 would be whatever the letter is, so just attach u to it, so it's just u, minus the integral of 5 over u would be 5 natural log of u, and then always plus our constant c. And then, like all of these problems with substitution, whatever letter I started with, so I started with x's, I need to end with x's, and then, well, that's back to our original u substitution setup. So those u's will become x plus 5. So this becomes, let's even put that in the parentheses. So this u is x plus 5 minus 5 natural log of x plus 5. And then still plus a constant c. Like that. Okay, so this is a variation. So we use this in only in special occasions, like this number 1, and we'll use it in number 2. Notice it wouldn't have been used in any of these from the previous video. So still start with those strategies first, and on these rare occasions apply this method. Okay, and then like always, you could check it. All right, so if we check it, well, the derivative of x is 1, derivative of 5 is 0, and then we have minus 5. The derivative of the natural log of x plus 5 would be x plus 5 thrown in a denominator. 1 would be up top. And so this needs some simplifying. It becomes 1 minus 5 over x plus 5. Getting a common denominator it would be x plus 5 minus 5 over x plus 5. And then the 5 minus 5 would cancel, and we're left with what we started with. Okay, so it does work. It's just it's a little harder to check. So sometimes it's tough to check. Okay, but that is the strategy. Okay, so that is how we break these down. Okay, and again, it's whenever you have some linear thing times a linear thing, or a linear thing divided by a linear thing. Okay, all right, but let's see how this one is. So this is a product this time. Well, before I jump into it, like most calculus problems, we don't like seeing radicals. So I'm going to rewrite that as 7 minus y to the 1/5 power, and then dy attached. And then, well, what we're going to do is use our u. Our u is most likely the expression that's raised to that power. So I have 7 minus y. And then our du instantly can be found. It looks like it'd be -1. And then again, attach the d whatever letter to the side. But even this, we can combine. Let's just say I'm doing an arrow. And we'll say du is negative dy. Okay, so I have du is negative dy, or the negative I can move to the other side. Negative du is dy. Okay, so I could use either one of these. So this is useful for us in either case. All right, so and then what I can do is continue looking at my integral. All right, so let's see what we've got. So I've got my integral. I've got 6. This y I'm going to come back to. Let's leave a space. But I do have this is my u. Okay, so I have my u ready. Actually, let's leave a little bit more of a space. Let me not do anything yet. Let me just color. Okay, so I've got that. And this is why I wanted to set this one up. dy is negative du, because I can change dy into negative du in this red parentheses. Okay, but this y is the problem. So this y by itself is the problem. I'm going to put it in green, which is right here where we would solve for y to help us. Okay, so if we solve for y, I would need to add y over. So I have u plus y is 7. Or at least that's how I'm doing it. I added y over, and then let me subtract u. So I'd have y is 7 minus u. Okay, so that's solving for y. So that was getting y by itself. And then now I can do all of these in the colors. I can sub them in. So the y is the same thing as 7 minus u. And then in the blue is just u. But it's raised to the 1/5. And then the dy we're saying is negative du. Like that. Okay, and then so at this point, I'm going to simplify our constants. So the negative and the 6 that I just highlighted, I'm going to rewrite so it's -6 and then the integral symbol. And then let's go ahead and just keep it in black ink. The 7 minus u and the u to the 1/5 and then du all still written. Okay, so why we wanted to do this is because with this way that it's written, I can now distribute. So this I can distribute into these two terms. Whereas up above, this y in the green cannot go into this because it's in a radical. So radicals don't go well with if you have multiple terms with them than if it's just a solo term like this. So this solo 1/5 powered u can distribute, and it just uses the rules for multiplying like bases. So we have -6 integral. We have 7 u to the 1/5. And then minus u. This would be to the 6/5 because the powers would add like that. So 6/5 and then du is just attached. And then now it lets us be able to use the power rule to continue. So let's do our power rule on this. So now I can do the antiderivative. So we have -6 and then doing the antiderivative. Let's keep it in the purple to show it. Okay, so I've got that 7 just hanging out. And then focusing on the u to the 1/5. All right, so I would add 1 to the power. So that would be 6/5. and then multiply the front by the reciprocal, 5 6. And then we have minus. There would be a 1 just to put a placeholder. Minus 1 would be there. But let's continue to add 1 to this power, which would make it 11 fifths. And then multiply by the reciprocal, 5 11ths. Like that. And then afterwards, we still have plus our constant. Okay, so we're getting there. We've got a couple more steps. Let's simplify our coefficients. So we have negative 6. I'm going to put parentheses. 7 times 5 is 35, so we'd have 35 sixths. U to the 6 fifths. And then minus 1 times 5 elevenths is 5 elevenths. And then u to the 11 fifths. And then still plus our constant c. All right, so we're pretty much there. The negative 6 I am just going to leave out. You could distribute it back in if you wanted to. But now let's go back to our original variable. So we started with y's. So that means I need to end with y's. And I've got my expression for that right there. So we can say that this is equal to negative 6, 35 sixths u is 7 minus y. Let me go ahead, I'll keep it in blue. And then that's raised to the 6 fifths power. And then we have minus 5 elevenths u, which again is 7 minus y. This time around, though, it's raised to the 11 fifths power. And then we still have plus our constant. There we go. Okay, so that is our answer for this problem. Let me fix that box. That's annoying. And again, we could check. I'm going to skip the check. It would take a little bit of time, and I think, I mean, if you want to check it on your own, you can do it. But this is it. That's our final answer. Okay, so if you do have questions, let me know. Otherwise, again, this is a unique case. Only when it's some linear expression times some linear expression is when we do this scenario. Otherwise, substitution is more like the ones that we did in these previous 4, or when we had the perfect substitutions. So these 7 are your general scenario substitutions. This is just a special case. All right, so use it when only needed. Okay, so other than that, though, thanks for watching, and I'll see you next time.